Hi, welcome to the fourth and final revision session on tectonic hazards within Unit 1 within the challenge of natural hazards. The last key idea here is that management can reduce the effects of a tectonic hazard. So if you manage the situation to the best of your ability, if you manage it well, you can reduce the effects. Less people may die, less people may be homeless, less businesses may suffer, and so on. So we're going to explore those ideas in this revision video. Right, first of all, we want to consider the reasons, so this is from the spec, the reasons why people continue to live near tectonic hazards. So if you can think about why people might choose to live in an area near a volcano, why would they choose that? Why would they choose to live in an area that's at risk from earthquakes? Okay, so if we start with a volcano. Now, there are quite good reasons why you might want to live near a volcano. You know that as the volcano erupts, ash is projected up into the atmosphere, into the air, and it will drop down and it will get into the soil. So the soil around the volcano actually has quite a lot of volcanic ash in it. Now, the volcanic ash has many minerals that are great for growing crops. They add nutrients to the soil. So quite simply, the ash creates fertile soils. So when you grow your crops, you end up with really good crops, really great yields. You might end up with really fantastic crops, really nice, big, large amounts of food that you can sell. So better crops, fertile soils will give you better crops, and from a farmer's point of view, that will lead to more money. And that's why farmers have looked to farm near to volcanoes, because the soils are absolutely fantastic. Okay, what other businesses might we see near a volcano? Begins with an H. You might have been to one. Okay, you might have hotels. So you may find that you have a whole load of hotels and people are enjoying walking near the volcano, taking in the amazing views, and so on. And that means that there are many jobs in tourism, and you can think about what they might be. So there are lots of jobs in tourism, hence people live in the area. There are lots of fertile soils, hence we have more farmers. You could also have other opportunities such as geothermal energy. So you can link this with the resources topic and energy. And I'll draw you a little picture. So imagine we're looking from the side. If underneath, down there somewhere, you've got magma, which is very hot. And then you run some water underground, take it back up again, water goes in, steam comes out, and if you put the steam through a turbine, you can spin it, and that will make you some electricity. And in a place like Iceland, the majority of their electricity is created using geothermal energy, which is fantastic. Okay, so if we think about these benefits, so that might make you want to live in the area, why would you live in an earthquake zone? Okay, so there are 2 points here I'd like to make. The first is that in these areas there are lots of fluids moving around, underneath the ground. And in both these areas, you can end up with minerals, metals that are deposited sort of along cracks as fluids are moving through the ground. So that's one thing. That might have attracted people to the area a long time before. The second thing that's worth considering is that as you look at the map that we used in the very first video, we can see that a lot of earthquakes and volcanoes run along the edge of continents, particularly around the Pacific. And so consequently, many ports and cities are on the coast. And for this reason, many of these cities and ports have large populations, and they happen to be in an earthquake zone. That wasn't the plan, that's just where they ended up. Now, this gives you some reasons why people might live in these zones, because they happen to be a port which happens to be on an earthquake zone, because they're attracted to mining, energy, tourism, farming, and so on. So if we take those ideas, just add a couple more that I'd like you to go away and think about. It may be that people are aware of risk now because they have more information, but they cannot afford to move. So if your family lives in Los Angeles and you're not particularly wealthy and that's where your job is and that's where your family are, it may not be an option to move. A quick note, can we just point out that often I have children, students will say cheap housing, and that's not correct. So although it seems counterintuitive, you'd think if it was an earthquake zone that the housing may not be expensive. Actually, some of the most expensive housing in the world is in earthquake zones. So we won't put that as an answer. But you could say that people cannot afford to move due to poverty. They may not believe it will happen soon. If the last large earthquake was 80 years ago, why would you be concerned when you've just got a busy life and you're going about your business? They may feel that there are good plans and protection in place, which we're about to talk about. So, be aware of this. And be aware of these positive reasons. And then if a question comes up asking you reasons why people continue to live near tectonic hazards, you've got some great answers ready to go. Okay, so we're now going to talk about managing tectonic hazards. And I'm going to ask you to remember the MP3 thing. Okay, can you remember what that's all about? So it's just designed to get you thinking about the three ways that you can manage tectonic hazards. So M, the first M, and then we've got three P. So M, P, P, P. We'll just start with one at a time. So M is for, can you remember? Okay, it's monitoring. So monitoring, if you monitor someone in a hospital, you might have pads and wires on your body. If you're monitoring tectonic hazards, what are you doing? Well, let's just go back to our volcano. If we're keeping an eye on this, what might we be looking for? We might note that the volcano starts to change shape. It starts to deform. Deformation happens. And that will happen because something's pushing up underneath, and that something will be magma rising, which is a sign that there may be an eruption. We may smell sulfur dioxide gas coming out of the volcano. And sulfur dioxide gas coming out of the volcano, again, is a sign that magma is rising. That's where it comes from, the stink bomb smell. If you've, when we went with the school to Iceland, went to a geothermal power plant, it smelled of rotten eggs, and it's this sulfur dioxide gas that we were smelling. You may have these tremors. Okay, we may experience tremors because, again, as that magma pushes up and it's forcing the rock apart, we may get these harmonic tremors as the magma's rising. It's quite possible you may start to pick up heat. And if there's snow on top of the volcano, that may melt. So heat is another important sign that something is going on. Okay, so all of these things are showing us that magma's rising. How will they be monitoring it? Well, for a start, in this modern age, they will be using satellites. So satellites will be picking up any deformation in shape. They may be able to pick up some of the thermal imaging. They may be able to pick up changes in the heat. And that information will be taken back to the experts. You may have laser measuring devices. So these laser measure, which measures from a fixed point to the side of the volcano. And if that distance changes, you know that the side of the volcano is deforming. You may have one of these little boxes on the side of the volcano that is a seismometer that picks up any earthquake or tremors that they can pick up. They have these quite cool little robots that they can send up into the crater that again can pick up signs of increased sulfur dioxide. So it's very, very important actually to monitor the volcano carefully with satellites, laser measures, seismometers, these little robot machines that they send up there. And why is it important? Well, if all of this stuff is giving you those messages, then you can start to make some decisions about evacuation. You're managing the risk. This looks bad. From experience, we think it's going to erupt. We're starting to see some small ash clouds coming off of there. Right, let's get everybody out. Reduce the risk to life. Okay, earthquakes. Can you monitor earthquakes? Well, yes, you can use a seismometer and you can see them happen in real time, but there isn't anything we can monitor. There were some suggestions, there were some sort of gases that may be picked up, but nothing so far is allowing us or allowing the experts to be able to pick up when an earthquake is going to happen. It's not possible to monitor and make a decision to evacuate. You can evacuate from around a volcano, not happening with an earthquake. So earthquakes, really just historical data. You know, do we see a pattern? Yeah, about every 100 years, maybe in one area, maybe it's going to be in the next 10 years. Okay, so that's the first section. So we can think about monitoring. If you can monitor, that will allow you to, I'm going to move down here actually, predict. So monitoring and prediction. So this means if you predict the future, you say what's going to happen and when. So if you can predict, make a prediction, you can say when it's going to happen. So based on what we've seen here, can we predict when a volcano is going to go up? Yes. And you can do it like this. And if you know the signs, because you've monitored lots of different volcanoes and you know about this area and you know about that type of volcano, then you can make some predictions and you can evacuate, keep people safe, shut down the roads in the area, get the tourists out. Earthquakes. Can we predict? No. Not with any accuracy. Possibly we could say there's a good chance it's going to happen in the next 10, 20 years, but you can't predict, and it is not possible to evacuate before an earthquake. Okay, you see it in films, but it's not true. At the moment, it's not possible to evacuate before an earthquake. So that's MP. We've got 2 more P's to look at. So let's have a look. So we've got MP3. So MP, the next P is what? It is protection. So protection is the next P. Now, if you think in terms of earthquakes, we can't get people out, we can't predict, we can't evacuate, so we have to protect, very importantly. So for an earthquake, the first thing you might want to do is make an earthquake-proof building. And this will be something along the lines. So if that's a building and that's the ground, then you might decide to have springs in the foundations, and these will isolate the building from movement, and it stops shaking. So if you think about the springs in the car, they stop you shaking on the back seat. So if you think about springs on a building, if the ground's doing this, the building will not be moving anywhere near as much, because the springs will absorb that movement. You may also have something called cross bracing. So within your design, you might have these crisscross structures, and these stop twisting and prevent collapse. So if you've got your springs in the basement, in the foundations, stopping the building from moving as much, and the cross bracing stopping the twisting movement, which again prevents it from collapsing. You might have a damper or a counterweight in the roof. And what these do, they're super clever. If you have, say, let's take for example, if this is your building and it has a weight here, if we're looking at it straight on, if the building moves to the side, the weight, counterweight, will go the opposite way. So it doesn't go with it and make it fall over. If the building, if we're looking at it from the side, this is the bottom, moves to the side here with the shaking, the weight will move to the opposite side and just bring it back, and then the weight will pull the other way, and it just stabilises it, reduces the amount of movement from side to side, and makes it less likely that the building will fall over, actually. And these can be hanging like a pendulum, or they can be on rollers or controlled. You could have things like automatic shutters to stop windows breaking, the glass going everywhere, and all sorts of other things. So this will keep people alive. We saw in Haiti, tragically, how this technology just wasn't there, and therefore so many people died. Okay, so earthquake-proof buildings is a really, really important one. You may also, obviously this is very expensive. A question that often comes up, or may come up, is this only possible in HICs or in more developed countries with more money? Well, you can create buildings from Something beginning with B? Building material that grows? Bamboo. So you might create some bamboo buildings. They might have some cross bracing. They might have roofs that are made from bamboo material. They might have quite deep foundations to keep them there. And if there's an earthquake, we may see that the building is flexible and it twists and it doesn't break. Now think about those buildings in Haiti that were made of breeze blocks and they just broke and crumbled and they collapsed and people tragically were killed in those fallen buildings. Well, this is very light. I mean, if a bamboo building falls on you, you're much more likely to survive than if a breeze block building falls on you. So it is possible in LICs and in NEs to use these cheaper building materials like bamboo to create earthquake-proof buildings. What scale can you do that at? Well, you'd have to think that through. And there's some good examples of these if you look online. Okay, so that's one way to protect people. You can create earthquake-proof buildings. You can also educate people. So if there's an earthquake, what are people educated to do? What do they tell school children to do? Okay, so they're going to tell people to get under tables. There's the drop hold and cover. So you get your head under the table, particularly why? Why are you going to be under the table? Why would you want to be here and not here? And that's because the table protects from falling debris, from falling pieces of ceiling. And the key thing about having your head under there is, God forbid your leg gets broken, that's bad. But your head is such a vulnerable part of your body that you need to have it covered. Okay, so last but not least, just have a couple of other bits and pieces here. You might, for example, choose to educate. You've got earthquake-proof buildings. Right, we've got the last P. The last P is protection, and the last P is planning. And this is where you have maybe your emergency services, plans in place. If you think about the response in Sendai in Japan, they had their emergency plans in place. You might have emergency supplies in place. You might have evacuation routes planned, so that if something happens, it all just clicks in. Everyone knows where they need to be and when. You might have supplies in your home. What might that be? You're probably going to need a water supply. You may want to have some food supply. You may want to have a radio with batteries so you know what's going on. You can listen in. You might want to have a torch with batteries, because in all likelihood the